In this video, we're going to solve an interesting equation. So we are first given that x comma y are real numbers. Y is non-negative, so it's bigger than or equal to 0. We're going to find x comma y pairs such that x plus iy multiplied by y plus ix equals ln of cosine of x squared plus y squared. Also, don't forget to subscribe and turn on notifications so you don't miss a video. Okay, I rewrote the equation. So now we're going to do the left-hand side, so we're going to expand this out. So we'll be left with x times y, which is xy, x times ix, which is I times x squared, iy times y, which is I times y squared, and now we'll have iy times ix, so we'll write the x first after the I, so it would be I squared xy equal the right-hand side. I'll just leave it for now. Okay. I squared xy, I squared is -1, so we have -1 times xy, which is minus xy. Xy and minus xy will cancel, so we'll have I times x squared plus I times y squared. We can factor out I to the back, so we're going to have x squared plus y squared, all multiplied by I, equals, so the right-hand side is ln of cosine of x squared plus y squared. Okay, good. We know an identity, it's special, e to the I theta equals cosine theta plus I sine of theta. So we can take e on both sides because we have something times I on the left-hand side. So we have e to the ln. E to the ln will cancel. Okay, on the left-hand side, we'll have e to this. Theta equals x squared plus y squared, so we're going to plug that in. So we're going to have cosine of x squared plus y squared plus I sine of x squared plus y squared. Now be equal to the right-hand side, which is cosine of x squared plus y squared. This wasn't pre-planned at all. Okay, cosine of x squared plus y squared will cancel on both sides, so we'll be left with I times sine of x squared plus y squared equals 0. I is the square root of -1, so it's not equal to 0, so we can divide by it. 0 times I and 0 divided by I is still 0, so we'll have that sine of x squared plus y squared equals 0. We can take the inverse sign on both sides, or we know that sine of what equals 0. That means the inside has to be equal to an integer times pi, so n pi. Okay, now let's plug this into the original equation. So the original equation on the left-hand side will have x squared plus y squared times I, when it's expanded, equal to ln of cosine of x squared plus y squared. That's it. So we want to find out which n values make this true. So x squared plus y squared equals n pi, so we're going to replace it, right? Yes. So n pi I equals ln of cosine of n pi. Okay. But let's see what ln of cosine of n pi, what does this produce? And n is an integer. Okay, so this will be element of. So what if n equals 0 to etc., etc.? So if n equals 0, we'll have ln of cosine of 0. Cosine of 0 is 1. Ln of 1 is 0. And for even numbers, it's the same thing. And then, what about for odd numbers? So ln of cosine of 3 pi will be ln. Cosine of 3 pi is defined to be -1. And ln of -1. So we have before that this identity, we can plug in theta to be pi, so we'll have that e to the I pi equals cosine of pi, which is -1, plus 0, because sine pi equals 0. So we have this, we take the natural log on both sides, so we have that I pi equals ln of -1. Now this is the principal value, there's other values, but we're going to be using these. Okay, ln of -1, we just found out, is I pi, so we'll just write that down. So that is the other type of values that this produces, that ln of cosine of n pi produces. Okay, so now we have that n pi I can be equal to one of these two values, so 0 or I pi. Let's just do one case when it's equal to 0, and then we'll do the other case when it's I pi. N pi I equals 0. I is never equal to 0. Pi is a number, so it's not equal to 0, so that means that n equals 0 is one of the cases. The other case is that n pi I is equal to I pi itself, and it can just cancel, leaving us with n equals 1. So we have that n equals 0 is one of the cases, and n equals 1 is the other case. let's use the n equals 0 case first. So we have x squared plus y squared equals n pi I, or n pi, sorry, yeah, it's n pi. So when n equals 0, n pi is just 0. So this means, and x squared plus y squared are real numbers, this means that x comma y has to be both 0 because they're both real. Okay, so this is one of the solutions to x comma y. The other solution is that x squared plus y squared equals n pi when n equals 1, so that would be pi. Okay, so, and we know that y is bigger than or equal to 0 from the original problem. So we can just solve for y. So we get y squared equals pi minus x squared. Take this positive square root only because it's bigger than or equal to 0. So we have y equals the square root of pi minus x squared. Okay, so we want y to be real first too. I mean, if it's bigger than or equal to 0, it is real. But so we want to find what x values make this true. So we can write this as x comma y equals, instead of x, we can use t comma square root of pi minus t squared, with the condition that t is an element. So under the square root, we have to have non-negative. So pi minus t squared is bigger than or equal to 0. This means that t squared is less than or equal to pi if you move things around. So we can write this as t is bigger than or equal to square root of negative square root of pi, excuse me, and t itself is less than or equal to square root of pi. So we can write this as bracket notation, negative square root of pi, comma, square root of pi. Okay, so, and then we also have the other case that x comma y are both equal to 0. And that is the end of the video. Hope you liked it, and thanks for watching.